myself, Raghav Tapadia. I am a mechanical engineering student from D.Y. Patil College of Engineering, and today we'll be discussing over the comparison of spur and helical gears. So in this presentation, we'll be talking about the gears and the importance of gear selection. Then we'll be looking over the types of gears like spur gear and helical gear. And then we'll be studying their comparison over uh, various parameters such as force analysis, strength, efficiency, etc. And then we'll be having a look at their applications. So gears is a mechanical component which has teeth and which is used to mesh together two rotating shafts for transmission of power, motion, torque, etc. It can be used to increase the speed or decrease the speed, and it is generally used in automobiles, gearboxes of industries, etc. And it works by interlocking of teeth, and it has various different types. In this video, we'll be mainly discussing over spur and helical gear. So importance of gear selection. Selecting an appropriate gear for an appropriate application is very important, as by this we can optimize the transfer transfer of motion, torque, speed, etc. Poor gear selection can lead to wear noises, wear, wear and tear, and energy losses. Choosing the right material and design enhances gear life and reliability under varying loads. So, for specific applications, we have to use specific types of gears, and otherwise, we won't get proper efficiency for our application, and the durability and the life of the overall system will be reduced. So, spur gear. Spur gears are simplest form of cylindrical gears with teeth cut straight and parallel to the gear axis. They engage suddenly, resulting in efficient power transmission but with more noise compared to helical gears. So as this definition says, spur gears are a simplest type of cylindrical gears, and the teeth is cut parallelly to the axis of rotation of the gear. And the load carrying capacity is the load is transmitted suddenly, which gives noise, and hence we have to use parallel shafts for the transmission of motion. This is the use of spur gear. Now we move on to helical gears. Helical gears are a type of cylindrical gears which are which have the teeth cut at an angle called helix angle to the gear axis, which is the axis of the rotation. As the contact is smoother, so it is a gradual contact between the teeth of the gear. The operation is smoother and quieter, and the load is distributed over the several teeth. And this gear can be used to transmit motion in parallel and non-parallel shafts. So the key differences are stated here in this slide. So the as we can see, the tooth orientation for spur gear it is parallel to the axis of rotation, and for helical gear it is at an angle called an helix angle to the axis of rotation. The force transmission in spur gear there is generally radial forces and tangential forces, and in helical gears the forces are radial, tangential, and axial forces, also called as thrust force. The engagement in spur gear is sudden and it is on a single tooth, whereas on helical gear it is gradual and smoother and distributed over multiple teeth. The spur gear has high noise and vibration, but it provides high efficiency. Helical gear has low noise and vibration, but it is providing slightly less efficiency. And the whereas spur gear has direct contact between the teeth, it has high wear due to sudden contact, and helical gear has lesser wear due to smooth contact between the teeth. Now we move on to the force analysis. As we have already discussed, the forces on spur gear are tangential and radial forces, And in helical gears, there are tangential, radial, and axial forces. Axial force is also known as the thrust force. The thrust force acts highly in helical gear because of the gradual contact and as the load is distributed between various teeth. Whereas in spur gear, the axial load is minimal or no axial load is there because the gear mesh in a single plane. And this also leads to low friction in spur gears as there is less axial force or no axial force. In helical gears, the axial force is there, hence there is more friction. Comparison of the spur gear and helical gear. As we can see, we have compared them on the basis of beam strength and wear strength. From the beam strength, we get the Lewis equation, which has four factors on which it depends: the module, the face width of the gear tooth, the stresses on the gear, and the Lewis form factor. In the helical gear, the equation is somewhat similar, but we get this cos xi factor, and the xi angle is nothing but the helical angle. Similarly, for the wear strength depends on four factors: face width, the ratio factor, and the pitch circle diameter, and the Brinell hardness number, which is K. And similarly, here in a helical gear, the cos square xi angle is added to the equation, which is to factor in the helical angle of the gear tooth. And the load carrying capacity is limited for spur gear because the sudden engagement and single line contact. And for helical gear, it can carry higher loads because it is a gradual contact between multiple teeth. Efficiency of spur gear is slightly higher as there are no axial force losses, and slightly lower because of the axial thrust leads to additional losses in the efficiency. The applications of spur gear are in mechanical watches and clocks, as the design is simple and reliable, and it is commonly found in simple machinery used in industries like conveyor systems, mixers, and low speed gearboxes. And it is employed in industries where the noise levels are less critical, and it is ideal for applications where the requirement of efficiency is high and the manufacturing cost that can be afforded is low. For helical gears, it is extensively used in automotive gearbox as the load transmission is smooth and it is giving less noise. And in aerospace mechanisms where high load capacity and compact design are important. And it is also used in heavy duty machineries like compressors, turbines, and elevators where less noise is critical factor. And it is also used in robotics and automation systems where low vibration and high torque transmission is required. It is generally used where the noise criticality is more, so we need quieter operations, and the manufacturing cost is also slightly higher. As the key takeaways of this presentation are, gears are used to transmit power from one shaft to another. It is also used to transmit motion and torque. And choosing the right gear is important because it leads to smoother operations. The efficiency and the torque transmission and other factors of the system are also increased, and we get a good life out of the system. In this PPT, we have discussed two types of gears, spur and helical gear, and we have compared them on various factors like construction, force analysis, strength, etc. And then we have taken a look of spur gear and helical gear. That's it. Thank you.